Hello everybody, welcome to this new Pix4D webinar. My name is Oliver Kung, I'm one of the co-founder of Pix4D. And today's topic is going to be about Pix4D Mapper app, as well as its combination with DJI Phantom Vision and Phantom Vision Plus. So today with me is my Vision Plus drone, as well as my smartphone to display this, to show this webinar. So, as usual, if you have any question, feel free to ask questions in the small question box, which is on the right on your GoToWebinar. Our support team is right there answering you live during the webinar, and I will pick up from time to time the most relevant questions to answer them during the presentation. And we will also have a small Q&A at the end where we can really discuss about any topics of the webinar. All right, so let's get started. So that's the plan of today's webinar. We're going to first talk about the Pix4D Mapper app. Why did we actually do an app, and why is it useful? Which drones are really supported, and what's the plan for support in iOS and so on. And then I'll go through a really step-by-step run of how you should proceed to really between having the drone and then getting results on your computer. Then the second part is a bit more on Pix4D Mapper processing. I'll also show a step-by-step how to go from DJI Vision images to a full 3D model. I'll give a very, very short introduction to photogrammetry to help understand a bit how this is possible. I'll have a very, very interesting talk about accuracy. So we did some accuracy assessment of the DJI Vision using our app and our software. What can you expect in terms of accuracy there? And I also talk, as it's related to accuracy, how to perform basic quality control on the results that you obtain with your DJI Vision. I'll first start with a quick poll. Oops, that's not the one. Always. Okay, I will not start with a quick poll as I don't find it. All right, so let's keep on doing the webinar. So here's why did we create an app? Well, to answer this question, it's fundamental to know that for accurate 3D modeling and mapping, the most important things to make our technology work is not that much the quality of the camera and the quality of the image. It's really the consistency of how much overlap you have between each images. So when you take pictures using a drone, you're basically covering a certain area on the ground. By taking multiple pictures, you're covering all the area with a certain overlap between each images. For accurate mapping, the most critical is really to get a high amount of overlap between each of the images. And this is what Pix4D Mapper app is providing you with the DJI Vision. So basically, a very good consistent overlap that you don't have to control by hand. Another big important thing is that Pix4D Mapper app takes also care of the overlap, the altitude, and the geotags. So by default, the DJI Vision has a very good GPS in it. However, for some reason, it does not write with the full accuracy the GPS inside of the images. And when you start doing a project using the raw images from your DJI Vision, you will get actually very inaccurate GPS, and this has a very bad effect on the 3D modeling with it. So that's another reason why we made the app, and it's working very nicely. Now, which drones are supported using the app? Well, of course, the DJI Vision Plus, so that's the one with the onboard camera, as well as the DJI Vision, which has the big wide camera, which is the same sensor, but it cannot turn. It can only move from up and down, and it cannot go totally down. So you have a bit of angle, which is fine with the software. Finally, you also have the DJI Phantom 2, so that's the one that comes without any camera, on which you usually attach a GoPro. Well, this one is not supported by the SDK of DJI, and thus we cannot support it in our app. We've got a lot of questions about the upcoming drone from DJI, the DJI Inspire 1. And if you buy it right now, it's not going to be supported in the following weeks. However, we got the promise from DJI that it will also be supported in the very near future by the SDK, and thus you'll also be able to control it with our app. That being said, this is really for the flight planning part. If you need to do image processing, then our software Pix4D Mapper is able to process any type of imagery taken by any type of drone. So you will be able to do processing in any of these different drones. However, if the images are taken in a very bad way in terms of overlap, then the quality and even the possibility to get some results is not very sure. However, if you use our app that makes a very nice consistent overlap, then it's almost certain that you'll get good 3D results at the end. Okay, so I just found the button for the poll again. So I'll ask a quick poll just to understand a little bit better the audience. So the first one that I'd like to ask to each of you is, do you already own a DJI Vision or Vision Plus? So let's just keep a few seconds there to let everybody answer. All right, so this webinar, about 44% don't have a DJI Vision. That means that 56% do have a Vision or Vision Plus. So, and now I can go on with my second question, which is, have you already used Pix4D Mapper app? All right, so I get 20% of the people have already used the app, which means that 80% of the attendees 40% of the attendees have absolutely no excuse for not using the app and trying out it tomorrow. Now, the good news is that we did quite a few updates already to the app since it came out last week, and the major update that we did in the last days were mostly based on stability. So the new app has now much more stable, doesn't crash as often, let's say, on the phone, and we also improved a little bit the possibility to go from doing a flight to doing to get a 3D model. So anyway, that means I'll go really step by step into showing the software and the app to present it, what are the possibilities and how it should be done. So when you start the application Pix4D Mapper app, you will be greeted with such welcome screen. And this is the same that you can see in front there. So this is how you should be doing projects. There are really main 3 steps into doing a project from beginning to end. The first one is to run a mission thanks to the app and to the DJI. The second step is to transfer the images from the DJI to your computer. The third step and last step is to run Pix4D Mapper software on your computer using the images and processing and generating 3D models. All right, that's the big picture. Now more in details. The first thing to do is to take your DJI and place it in a clear area on the ground. Try to have something like 10 by 10 meters around you of free space. Very important, you need to have GPS access for the DJI to start. We require usually to even allow the drone to start flying to have at least 7 different GPS that can be taken by the drone. So make sure that you have a clear area without too many buildings around you. Then do not power yet the drone on. Do not yet power the drone on. Keep it really nicely shut off on the ground. Then the next step is to start your smartphone and to make sure that you have the latest Pix4D Mapper app from the Play Store. And then you are greeted with the screen that's in front of the eye there, and to start by pressing Grid Mission. There you have the view of the main screen. Basically, with your finger, you can move, zoom to the place where you want to map. You can use the small button there to center on the screen, on the place where your phone is reporting where you are. To place the survey zone, which is the one which is in green here, you can press on this button there, which will center the survey zone to the center of the screen. So basically, you move a little bit the screen to where you want to survey. You press on place the survey zone, and then this way it's quite easy to find the place where you want to map. By default, you have an area of about 100 times 100 meters. If you want to change the size of your grid, you have to go back by pressing the home button and going on the settings. And there you have a few parameters that allow you to change the size of the grid to make it a bit bigger. We computed that the values that we allow for make a grid are basically the value that is manageable in one single flight of the DJI Phantom Vision Plus. So with the value that we put, usually you won't have any issue in terms of endurance. And these zones can be easily covered with one single battery. There's a map which is displayed on the background, but only if you're connected to the internet. So as long as you didn't start your drone, you probably will have internet connection from your cell carrier, and then you'll have the map downloaded in the background. Okay, once you have decided where you want to place your survey zone, now you can start the drone. And I guess most of you will recognize the sound of this of the vision starting up. After powering the drone, you still need the remote control and the Wi-Fi extender. So power on the remote control as well as power on the Wi-Fi extender. A very important thing is on the remote control. you have these two little switches on each side of the remote control. And when I first got my DJI, I never knew what actually it was for. So let me tell you what it actually is for. The switch S1 should be in the top position. Top position means that you allow the application to control the drone doing a mission. If it's in the bottom position, this means that you interrupt the mission and you take over manual flight control. So make sure that before starting a mission, the switch is in top position, but if any case you have an issue or problem, a danger, the drone going in the wrong direction, make sure that you quickly switch and then take back control of the drone. Okay, once this is done, basically you can click on Start Mission in the app. When you click Start Mission, it will not directly start the mission. It will actually trigger a screen, which is this one, which lets you connect to the drone using the Wi-Fi settings. So if you go in the app, basically either you're already connected because you already connected previously on the drone and Android is going to connect you automatically to it, or the other way it could work is that you basically need to connect to the drone manually. Once this is done, you can press Next. And you get some, you have some instructions that we really recommend to read before the takeoff. And that basically the instructions are about our reminder about this S1 switch that you can put down anytime to take control of the drone in case of emergency. Once this is done, you can press for takeoff. You leave your finger pressed for 3 seconds. You wait a little bit, and you will see that the drone will automatically start to take off, and will go about 50 meters high before starting to move into the waypoints that are defined for the mission. Now, just as a tip, if you want to try a bit more difficult things, you can also start to fly the drone manually, go into some area where you feel it's safer to start the mission, and only then start and press the mission. So it will not take off again. It will basically, since it's already in the air, it will directly go to the mission. And you can also start the mission without having to start it from the ground. So you can start it from anywhere. So we really recommend that during the mission, you keep your hands on the control, on the remote control, to make sure that if there's any danger of any issue, you can always switch back to manual control and take back the control of the mission. You can also note that on the application, there's a abort mission button. If you click on it, then the drone will automatically come back to the home point, and the home point is where you started the drone from the ground. In case that the battery is not sufficient anymore, the drone will also automatically abort the mission and come back to the home point, and that's usually around 20%. If the application, for some reason, or your smartphone, maybe there's no more battery or anything, if the smartphones stop functioning during the mission, don't worry. The mission waypoints are transferred to the drone at the beginning of the mission, and then it's fully autonomous. So if your application or your phone crashes in the middle of the flight, the drone will continue the mission as usual and land back at the end of the mission to the right spot. However, the images will not be taken anymore. So taking the images is controlled by the application and not by the vision drone. So make sure that you have, basically, if something happens, you'll have to redo the mission. In this view, you will also see that you will have the updates of the drone position, so you can follow the progress of the mission to make sure that it's not stuck or anything. At any time, you can also switch by pressing on this camera button, and by pressing there, you will have a live video. You will have access to the live video feed, so you can basically see what's happening also there. So once it did its mission, so for a small grid, maybe you'll have something like 30 to 40 images. For the largest grid, you will have something like 100 images. So it will come back to the home points and start to land. While it's something to make sure is that even though it has a GPS, the GPS is not the most accurate thing anyway. So it might land a few meters away from its home position. So that's one of the reasons why I recommended at the beginning to have quite a clear space to do the takeoff. And also something to know is when it's doing the landing, and you can see that it's going to land in a place which is not the place where you'd love it to land, for example, on a slanted corner or something like that. You can always take manual control of the drone and then do the landing yourself in a different area. Another tip, again, a bit more for advanced use, when the drone is landing, you can also catch it from the bottom, and automatically, in a few seconds later, the drone will stop its propeller, and then you can use it. You can put it on the ground yourself. While it starts landing, the drone will start to send all the images that it has taken wirelessly to your smartphone. So it's as soon as it's landing in landing mode, you will have a small pop-up saying, please do not turn off the drone. The image are transferring. It takes about a few seconds for each of the image to transfer. So if you have 100 images, you may have to wait 5 minutes with the drone landed to keep doing the transfer. Make sure, it's very important, not to interrupt this. Otherwise, the geotags, the accurate geotags will not be saved. So make sure that this does not happen. All right, so after the image transfer is completed, you need to move so the images are then on your phone, and then you need basically to move them from your phone to your computer to make sure that you can start doing the processing and get the maps and the 3D models. So to do that, there are several ways to do that. The first one is, since the update of yesterday or the day of before yesterday, after a mission, you'll get a small pop-up asking you, do you want to transfer the files using a files transferring service? So you'll have the possibility to either send the images through Dropbox, if you have Dropbox installed, or whatever Google Drive sharing services, or you can also just have the P4D file that has been generated, which contains all the information about the flight log and the GPS, and you can send this P4D file through email to get it directly on your computer. If you don't do this way, then you can also just skip this step and then plug your smartphone to your computer using a USB cable and transfer manually the images from your smartphone to your computer. However, and something that's pretty important to note, do not, and I'll repeat again, do not take directly the SD card from the drone and plug it in your computer. The reason is that the images which are on this SD card have very, very bad geotags, as I explained in the very beginning. If you start a processing using simply the images on this SD card, the results will likely not to be optimal at all. So what we suggest is either to transfer the images which are on your phone, this one have the good accurate GPS, or to use these images together with the project file that was generated on this phone. So if you transmit the project file from the phone to your computer, then in that case, you can either use the images from this phone or the images that were on the SD card of your DJI. And then once you have the project file on your computer, then you simply have to double-click on the mission.p4d, and this will, if you have installed Pix4D Mapper on your computer, this will open the software, and the only thing which is left to be done is click on Start Processing to start generating all the different products of Pix4D. All right, I'll make a quick break right now to start answering on the questions that were asked during this step-by-step run-through. So give me a few seconds to read through the question. So will the app support the DJI Inspire 1 in the future? Yes, it will. That's a very good news. We got the confirmation from DJI. The only thing we don't know is when, but it will. What is the SDK? Who can use it? So the SDK is, let's say, a tool developed by DJI, which allows company like Pix4D to be able to create application that control the drone. And we are the first partner of DJI to do so. Can you use the app without using the software Pix4D Mapper? Yes, so the app is really controlling the drone, and then it makes a bunch of images. However, to take the full advantage of these images, we definitely recommend to use Pix4D Mapper to process them. When is an iOS version going to be available? So we are already working on it. So we have a team of developers working on the iOS version. So that's the good news, but the bad news is probably going to take a few more weeks, and we try to have it ready by the end of the year, beginning of next year. Let me go further questions. Oh, there's a lot of questions happening. What firmware version do I need to have on the DJI drone? The latest, obviously. So that would mean 3.0.6, both for the DJI Vision Plus and the DJI Vision. However, we bought this one just recently again a few weeks ago in the stores, and they come directly with the 3.0.6. So for the new drones you buy, for sure, you don't need to update anything. If you bought it a long time ago, maybe you have to check if you need to update it. Can you save the map data while in self-service and use it once I leave the self-service area? Right now, you need to have it. You cannot close the application between having the map and starting the mission. That was actually from a bug from the map service we were using. So they fixed very recently that. So in in one of the next updates, we will be able to cache an area you need to map in a few days before or anytime before, and have it ready for when you are in the field. So this is a feature that's going to come quite soon. If you take manual control, will it cancel the mission but keep the pictures before taking over, or do you need to start over? So if you take control, of the mission in the middle, it will not right now transfer the files and create a P4D file. So if you abort the mission, you will have to restart it again. But this is something we're working on to make sure that even if you do half a mission, you can still use the images and the project file to process them. How do I know when there is an updated version of the app? Well, this normally should come automatically. So just the Play Store will make sure that it will be, you will get always the last updated version. Can two missions be combined together? Yes, it's definitely possible to combine as many missions as needed. Not in this app right now. You need to create a mission for each of the different parts. But as long as you have a little bit of overlap between two missions, then it's very easy to process them either individually and then merge them later on, or to do everything together. Every time there's an update, so Android is going to notify you, and if you go on the page of the application, you will have a small box which will going to let you know about the updates, about the change logs, what did we improve and what did change. All what I explained also right now about the different step-by-step about what you need to do is also, we just updated this morning the tutorial help section of the application. So if you click there, you will have access now to a very detailed step-by-step of everything what I just told right now. So yes, as there are still questions about it, about the iPhone versus Android, unfortunately the app is right now only Android, and we will have Apple iOS, iPhone and iPad version before the end of the year. A very interesting question about Pix4D for the cloud. So right now I was mostly discussing about how to transfer the images from your smartphone to your computer, and indeed we are really working right now also in parallel of having directly the cloud service on your smartphone. So the goal will be that in the field you can do the image acquisition, it will transfer on the phone, and from your phone you can then send it through your 3G or 4G to our cloud service to start automatically the processing and give you the results right away in the field. When the free flight mission will be available, also we have tons of different features to work on. So we try to get it something by the end of the year, but no promise on that. Will the app vary the altitude of the Phantom vision during the survey? And also as a side question, is that necessary when modeling buildings and other structures? So maybe I will answer that at the end of the presentation after showing a few results of the application inside of Pix4D Mapper, so you can have a better feeling of what's possible to do with the app and the Phantom Vision in terms of 3D maps. And let's go directly to the next. Sorry for the people I could not answer. There's really a lot of questions right now in the chat. So I'll keep a few of the questions for the second part of the presentation after showing the results of what can you expect in terms of results inside of Pix4D Mapper app application. So let's go back in the presentation. All right, so let's take a project. This would be one. So once you transferred the images and the project file from your smartphone to your computer, this is what you'll have. Basically a P4D file, which is a Pix4D mapper project file, together with a folder containing the images. And basically this is Pix4D office. We are right now on the 4th floor, and tomorrow actually we're moving to the 3rd floor, which is this building right there. So if you have Pix4D Mapper installed, the only thing you need to do is double-click on P4D file, and this will open the Pix4D Mapper software. So I have 2 examples there. Oh, by the way, once it's once you open the project file, you will be in the map view, where you can see the nice geotags recorded in the P4D file. You just need to press on the local processing dialog, click on start, wait anything between 10 minutes to an hour, depending on the power of your computer and the size of the number of images you've taken. But for a small project like this one, which is about 40 images, on a quite good computer, it took 10 minutes for doing the image calibration and about 7 more minutes to do the point cloud densification, the 3D modeling. So here you can see that this was the flight grid that was done. The blue dots are the position of the GPS, and the green dots are the optimized value computed by Pix4D mapper. And in terms of 3D rendering, these are the things you can achieve with it. So here it was using the grid flight, and the camera was pointing exactly to the ground. However, as we are flying right now, the application is designed to fly at 50-meter altitude. And at 50-meter altitude, as it's a fisheye camera, you see a lot of the facade of the building. And in this data set, even though the camera was pointing down, it captured a lot of the sides of the building. And that's why in the 3D model, you get to see the sides of the building too. The ground sampling distance is around 1 to 2 centimeters on the ground, so it's actually pretty precise. Let me show you. So that was the data set done with the Phantom Vision Plus. Now let me show you another example. So this data set was done using the Phantom Vision, not Plus. So the Phantom Vision has not the ability to point the camera fully down. So each of the images are slightly tilted. However, for the software, it's not an issue, and actually it's even a benefit as it gives you more facade imagery and improve the rendering of the facade. So what I'm showing right there was small grids. That was not a 100 times 200 meter grid. That was more like 80 times 80 meter. So you can cover much more distance than what I'm showing right there. Okay, so a little introduction on photogrammetry to get a better understanding of what happened between taking the images and getting a 3D model. So the whole concept is based on image matching. It's based on comparing the different images, and by doing enough computation, you are able to find back the 3D dimension that you lost when you took a picture. So when you take a picture, you are losing information of the distance to the object, and as well, because you have perspective, the objects are changing shape. So objects which are very far away will be very small on the image, and objects which are very close to the camera will be actually very big in the image. And thanks to the change of the object size, we are using multiple images. It's possible just purely from images to compute back the distance to this object. If you have the distance, basically you have the whole 3D model. And if you have the 3D model, you're able to do measurements in a very precise way, and you're able also to rectify the images to remove the perspective. And this is what allows you to generate a map, what we call automosaic. An automosaic is a stitch of all the images, but it's not just a simple stitch. It's the stitch in which you also remove the effect of perspective. So this way, it allows you to have really as if it was seen from satellites. And the very big advantage is that it's possible to do measurement in automosaic, as the dimension will be perfect. So there are tons of webinars that we already did at Pix4D that you can look on our YouTube channel, which explain during hours how really this whole process is working and what is the effect on the calibration and on the results. But basically, just as a quick overview, the images are analyzed. When they are analyzed, there will be some key points, some places where the software will look for and try to match them across other images and make correspondences. This is what we call key point matching. I just draw here on the example 5 key points, but in general you'll have tens of thousands of them in each images. Once they are matched, we are able to try to find the position of the images, the real position, the accurate position, and the positioning of the images is much better than what you get with a GPS. So it's really based on image content, which constrains the images in such a way you are able to find back what was the real position and also what was the internal shape, or let's say calibration of the camera. How does the perspective affect it? So from that we're able, and this is what happens in the first step, is that it's going to orient all the images correctly and make sure that we are able to find a internal mathematical model where everything fits nicely together. In the second step, we are computing then a point cloud. So that's really a 3D representation of very details of the terrain. And from that, we're able to compute a DSM, which is an elevation model that gives you an image for each pixel. You have the altitude, and from the DSM, you're then able to compute the automosaic. So this is the map which allows you then to represent quite a wide area as if it was taken by a satellite. So maybe the take-home message for people who are not familiar with photogrammetry of the small slide before is everything is derived from the matches between images, because everything depends on that. And if you don't have sufficient matches, then basically the whole thing collapses and doesn't work well anymore. So the most important is to have a lot of matches. And the best way to ensure that you have matches between the images is to have overlap. And that's why we created the app, to ensure the overlap, as I mentioned in the very, very beginning. Now, a small trick on overlap is that overlap depends not only on the distance between the images, but also on the altitude of the object. So basically of the distance between the camera and the object you're trying to shoot. So if you start, and that's what I try to represent with these 3 drawings, if you fly at the same altitude with the same distance between each images, which is what Pix4D Mapper app is doing, by default, if you have, if everything is very flat, you'll have high overlap everywhere. However, if you have objects like houses in it, on the top of the house, you will automatically have less overlap because you're closer to the camera. And if you have an extremely tall building, then it may happen that you actually don't even have overlap. So that basically just a reminder that it's important that you should not expect to have amazing results if you are too close from the images and that you are keeping the same overlap. So the bad news is that right now in Pix4D Mapper app, you cannot change the overlap. We set one by default. The good news is that for most of the cases, like the one I displayed just earlier, it's plenty sufficient. So even if you have this type of buildings, the overlap on the top of the roof is still enough to ensure good quality mapping. This is definitely one of the big improvements we also do to the app to let users change the overlap, change the altitude, and have much more control over that. So as a note, right now the app is making the drone fly at an altitude of 50 meters, more or less, depending on the accuracy of the altimeter. And it's right now only flying at a meter of 50 meters above the ground where you started the drone. Now I'll talk a little bit about quality control, as it's important to note that even if it looks pretty, it doesn't mean it's accurate. This is one big fallacy of all the 3D point cloud that we generate. They usually look very good, but there is a bit more to do to ensure, if you really need accurate mapping, to make sure that it's actually really accurate. And the software is helping you in that, but you have to know where to look for. So the first thing that we generate at every single project process is a quality report. There you have 5 checks, which are really worth to check, and there's a lot of help which is built in the software to help you understand a bit more about it. Then there's ground control points, which are definitely something to check also. That allows you to gain absolute accuracy versus relative accuracy. Manual tie points. For that, I will really encourage you to watch a webinar which was done on this topic about ground control points and manual tie points to really understand how you can assess the accuracy of a project. And then there's also manual tools that we have in the software that lets you edit the results to improve them. So I'll quickly go over for one of the projects, let's say this one, on the quality report. So you have, every time you have the icons, you can click on it to get more help. You'll start with this quality check, which has the 5 icons there, which give you hints about the accuracy and how much can you trust the images. If everything is green, it's a good sign. When things start to get yellow, then you should really click on the small question mark to know more about it. And if it's red, you're probably doing something very wrong. And it's worth reading what's happening. It will help you to also understand better all the different parts of the quality report to get more insights about the accuracy. So talking about accuracy, we did some tests on the data that I just presented on the 2 projects that we flew a few days ago that I just presented in this webinar. And what we did is we really took the drone, we followed the instruction I gave, we got the images back on the phone, transferred the images, and started the application. We computed the 3D cloud of points, and then we used the Ray Cloud, which is the 3D interface inside of Pix4D Mapper, to do some distance measurements. So we did the measurements, we reported them on an Excel sheet, and then we went outside with a piece of tape, and we started measuring in reality the distances at various areas in this project. And then we reported them back and we compared the values. So here you can see 1, 2, 3, 4, 5 distances that we measured. And that's what you can see, the comparison between the distance we measured and the distance we got in the Ray Cloud. And basically the answer there is that in the worst case, in our small test, you were 3 centimeters away, but most of the time you're within 1 centimeter. This is an excellent result, and this is relative measurements. It tells a few things. It first tells that the images are of are enough of a quality and the overlap was sufficient to generate a good project. And in addition, it also tells that the synchronization and the way that we read the GPS information of the drone is good enough to have the right scale computed. So now make sure to note that we didn't use any ground control points in this mission. This means two things. You don't need necessarily ground control points if you just need to do relative measurements. However, if I would take a point here and compare it to a point measured with a professional GPS, I would probably see a few meters of inaccuracy. This is due to the fact that you have a consumer-grade GPS inside of the DJI, and consumer-grade GPS always have a few meters of inaccuracy versus the absolute reality. So it does not matter too much for relative measurements. So if you need to do distance and volumes, you will get very, very accurate results. However, if you need to get a point and to compare it with in absolute way with other data that you collected with a professional GPS, then you may have a few meter differences there. And the way to correct for that is to introduce ground control points using a professional GPS. And again, I would encourage you to watch the full webinar which is done on this topic to better understand what I mean with that and what you can achieve. But now, on the other hand, if you would take a professional GPS, take 3 ground control points in this data set and introduce them in the software, then you would very likely be able to have a centimeter-like accuracy, global accuracy, absolute global accuracy for this project, which is very impressive. Now I'm just going to talk a bit more on the outputs that are possible to do using Pix4D Mapper and a little bit of the tools which are included in it before finishing the presentation with the Q&A on going over more questions that were asked during this webinar. So the outputs. In Pix4D Mapper Discovery, which is the free version of the software that you can download directly right now from our website and use without any limitation, there are 2 possible outputs. You can output a movie about the 3D fly-through of the point cloud you just generated, and you can also do single point measurements. So if you want to know the location of a single point in the point cloud, then you can take it and you will get the measurement. If you want to go further and you need to do more things with the software, then basically you can at any time rent or buy Pix4D Mapper Pro. And with Pix4D Mapper Pro, you can generate automosaic, elevation model, point clouds, contour lines, and much, much more. Volumetric measurements, distance, you can export all the measurements you did and so on. So let's go quickly for a few examples. So in Pix4D Mapper, you can basically, if you want to get the volume of this bench, first thing you can do is use the ray cloud to make sure that the bench is exactly what you can see in the images. Right, so that's indeed the bench, seen from all the different angles in the images. And you can use, for example, the volumetric measurement tool to quickly select around. And there in the volume, you get directly the volume computed of this object. You have also the possibility to do very accurate measurements of distances by going in the ray cloud, selecting 2 distances. pointer is a bit big. Let's change the size. And by clicking on the line, you can see that I didn't exactly click on the right points that I wanted to do my measurements of the roof of this little house. And you can see in the reprojection of the images that indeed I clicked not exactly on the border of the images. So Pix4D Mapper also allows you to do refinements in the images and to really go precisely to adjust the measurements to make sure that you're measuring the right thing. And this is really the tools that allows you to get centimeter precision measurements from the DJI Vision. A few of the other tools that we have is a mosaic editor. So you're able to generate mosaic from directly from the results, as well as an elevation model. And maybe I can show also the animation tool that allows you to basically go around the model, record a few waypoints, and generate a 3D animation of the model. As I'm using actually a very, well, let's go on. If you want to know more about Pix4D Mapper, then the easiest is to download the Pix4D Mapper Discovery and get yourself, try it yourself. Otherwise, there's plenty of documentation either in the support website, in the webinars, and other places to get information about all the possibilities you can do. So maybe I'll go back now to the webinar questions, and now we can go more into question and answers, and I'll try to answer as many questions as possible that were asked during this webinar. Do you support outputs to ArcGIS? Yes. So all the outputs that we generate are, most of them are compatible with ArcGIS. We even do have a whole webinar which is in this topic, how to export the results from Pix4D Mapper to ArcGIS and to AutoCAD. So there's a whole, we really explain in details all the different possibilities and the workflows. So this is pretty nice. There appears to be missing data in the model. How do we mitigate that? That's a good question. So right now, why is there less data on some parts of the building? The reason is because the overlap at that spot was not enough. The best way to mitigate that is in a next update of our Pix4D Mapper app flight planning software. We will be able to you will let settings for the user to take more images when you have such a difficult object such as this building. Now I'm also going to show quickly, as I'm using not Pix4D Mapper 1.2, but I'm already using a preview version of Pix4D Mapper 1.3, which also supports now full 3D mesh. So there I just click a small button, and now you can see the full 3D mesh version of the point cloud. So this is not a point cloud anymore, this is a 3D mesh, which doesn't have the holes that you could see before. So this will come by the end of the year. This version of the Pix4D Mapper software, which is able to basically also make sure that you cover all the areas. Will you be able to set the camera angle of the Vision Plus for better facade and vertical capture in the app? Yes. Two things about it. One will be in the grid mission to allow a bit more angle during the pictures. So this function will come soon, and to make sure that you can do really very detailed facade, that's where we have the possibility to do the free flight, which is written coming soon. This is also something we're working on to give even more freedom on how to take pictures for facade. Somebody asking about if there is possibility to do manual scaling in Pix4D Mapper Discovery. Yes, it's possible. So the good news is that if you use the GPS of the drone recorded by the app, you don't need to do that. The GPS is of sufficient quality that the scaling will be perfect, and you don't need to change the scaling of the 3D model. Now, how to change the scaling of the model, if any way you actually want to do that? The easiest way is to introduce a line of a well-known object, let's say this one. Make sure that actually the line is covering the right object. So this is in that case, you can see that I clicked actually wrong, the wrong way. I can, however, refine by adjusting in the images there. And by using now this generate, when I created this line, this created two manual type points. The manual type points are over there. These are the manual type points. And then the one on the bottom, I simply have to convert it to a 3D GCP and to put as coordinates 0, 0, 0, apply. And then on the second one, I convert it also to a 3D GCP, and I set the coordinates 0, 0, 1, apply. And then I will click on the button there, reoptimize, and this will scale the model to make sure that the distance between this and this is 1 meter. I lost the question panel, which is there. All right. Are the results the same quality if we use different version of the Phantom drone? What if we use another DJI with the same camera as the Phantom Pro? That's a very interesting question. And it's always a bit the question about what matters most. Is it the flight plan, or is it the quality of the camera? And one of the answers that we discovered by processing tons of data sets is that the flight plan is really critical to get good quality results. So in a sense, even if you have a great camera, but your flight plan is not good, the results will be terrible. And if you have a decent camera, such as the one as the DJI, and you have a great flight plan, then the results will actually be pretty good. So being said that, the application, so if you can ensure that with the other drone you are using, you have a very good flight plan that ensures a lot of overlap, and you have a better camera than the DJI, that's the one that's embedded there, yes, the results will be better. But only if the flight plan is also a good one. A question about, does Pix4D Mapper Discovery let you measure lines? Indeed, no. Pix4D Mapper is limited to measuring points. If you need to measure lines, then you need to switch to Pix4D Mapper Discovery that you can get, you can rent for just a month. Is there some other software for the other drones? So we are working right now to make our application also compatible with other drones. And then there's already existing drones in the market which have which we are collaborating with, that you can see on our Pix4D mapper, on our Pix4D.com website. We have a partner, and you can already see the partners which we are working with, and all of our partners have built themselves a flight planning software that ensures that you have the decent overlap. All right, somebody asking about the project file, that he did a project and the project file was not there. Where is it? Only the images were there. So that's basically because you were using a version that's older than a week. We updated this week the software to be able to create directly P4D files. So make sure that you redo the mission with a new version of the software. What's the minimum number of passes? For example, if you have several straight miles of right of way, would 2 passes be sufficient? Actually, in theory, 1 pass is enough. However, with 1 path, you have the risk that you start having error accumulation and the accuracy will not be preserved. So we definitely, when you need to have a straight line, we recommend always to do at least 2 passes. And anyway, you need to usually get your drone back, so that's a good thing to do. So 2 drones would normally be sufficient, but if you can do more, that's even better. Will other map sources be supported in the future? Yes, we're also planning to, now we're getting feedback, especially from Canada and from South America, that the maps are not of good quality there. We also try to have other map providers in for the app. Okay, somebody asking, can you convert the point cloud data to a true textured 3D? So this is what I exactly showed just before in the software. So that's going to be an upcoming feature of Pix4D Mapper 1.3, where I could already show you a preview of, and this will be released in by the end of the year. Are the survey control points on the facade of the buildings recommended for more accurate production of the model? So that's a very interesting question too. For this particular case, you can see when you go back not to the point cloud densification, but in the manual type points. Maybe let's show the other data set there. So in this data set, let's switch the densified point cloud and just look at the automatic one. One thing you can see is that there's very little automatic type points on the facade of the building. So there are 2 reasons for it. One is because the overlap was on the low side of it. So more overlap would definitely help to make it better. And it's also a difficult part. So in this particular model, I think that adding a few manual type points, not ground control points, but just manual type points, would help to improve the 3D of the facade here. Ground control points, so the one that have a coordinates, this one I don't think it's worth to add them on the facade of the building. They will mostly be helpful for improving the geolocation of the project, not of the individual part of the project. Can I do a large area and then divide it in 5 missions or more and combine them all in one single project? Yes, it's perfectly, as mentioned before, you can do 5 flights, 5 missions. However, you have to make sure that you have a bit of overlapping between all the 5 projects. That makes the processing much easier. And if you have this 5 mission, then in the software in Pix4D Mapper, when you create a project, you can merge multiple P4D files to generate one single big automosaic. Will the app support non-vertical elevation data to keep the UAV at the same distance from the sloping ground? Yes, so that's something we're planning for sure. But right now you can get quite good results already, even keeping a fixed distance. So for the ease of use, it's easier like that. But that's definitely some of the suggestion of which we want to add for the planning. How well will the mapping will be done of a highway when there is moving traffic? That's a very interesting question too. So moving objects, if they move fast enough, they will not be used in the 3D reconstruction because they are not consistent between all the different images. So if you do it over a highway and you take enough images, then the elevation model will very likely be of very good quality. If there is a huge concentration of car, a lot of traffic, then the mosaic will probably not be very good. But if you have not too many cars passing by, you actually will get very good data, and you can use the mosaic editor tool that we have inside of Pix4D Mapper to make sure that you are choosing the right part of the highway without having ghost cars in it. But then, now thinking just about it a bit more, it's probably not a good idea to fly your DJI over a highway. In many countries, it's forbidden, and where it's not, just for the sake of it, I would maybe not try to do it, as you don't want to know what happens if, for some reason, some of the rotors break down during that. That's a very, very nice question. How hard would it be to do a 3D map of utility towers? Would app provide enough overlap to get a good 3D image of the tower? We have very good results already now with utility tower. But for that, we would recommend to use the free flight mission that will be available later on. Sorry, we don't have a date. But for utility tower, you can do very accurate mapping by flying around it at different elevation with the camera looking something like 45 degrees down. So this will be possible to do in the future as soon as we have the free flight inside of the software. That's a very recurrent question. Is this webinar be available as a video at a later date? Yes. All webinars are always recorded and are on our YouTube channel. And by the way, we really recommend to subscribe to our YouTube channel, so you'll always get the updates to know when there will be when there's a new webinar for which maybe is for your specific topics. With this, I'll maybe conclude the webinar. I didn't answer to all of the questions. I'm very sorry for the questions I could not answer right away. However, our support team is still there and still answering manually to all the questions, so it should arrive very, very soon. So I hope you enjoyed this webinar, and I hope that for the 40% of you that have, actually the 50% of you that have a DJI Vision, that you will actually try to do a mission using Pix4D Mapper, and I hope you'll have great success. We have already on our YouTube channel also quite a bunch of results of people that tried to do 3D reconstruction and then use the 3D animation tool, and we are collecting them to have them on our YouTube channel. So feel free to, whenever you have a really nice 3D looking reconstruction, to share it with us so we can also advertise your project. So thank you again very much for attending this webinar.